For this video, I'm going to go through a volume and surface area question related to this cone. The surface area question is not included, but I'm gonna add it there just to cover all the bases related to the three-dimensional questions. So a cone has dimensions shown in the diagram. Point B is on the circumference of the base, point O is the center, and A is the apex of the cone. You need to calculate the size that AB makes, the size of the angle that AB makes with the base of the cone. So the angle that AB makes with the cone is this angle, so we're looking at it here. And you can clearly see the right angle here, AOB, that is shown. So for part A, we're looking at the right angle triangle AOB. Because it's a right angle triangle, we can use the trig ratios. So we have AB as 8, OB as 2.5. We can find AO, but right now it's not necessary. This is the angle we're missing. And we can start labeling. So this will be our hypotenuse. That's the first thing you label, and then this will be the adjacent angle. And so we will have to use cos in this case. So cos of our missing angle is equal to the adjacent, which is 2.5, divided by the hypotenuse, which is 8. And so our missing angle is equal to cos inverse of 2.5 divided by 8. And this whole thing is equal to 71.8 degrees, and that's the three significant figures. So fairly easy, straightforward. For part B, section I, we need the height of the cone, so we need OA. And again, we can use this right angle triangle. The fact it's a right angle triangle, we have two of the lengths, which means we can just use Pythagoras. And that is 8 squared minus, because 8 is our hypotenuse, so minus 2.5 squared. This is 57.75, and you can leave it at there if you don't want to round your answers too soon. Otherwise, this is 7.60 centimeter, again to three significant figures. For part 2, calculate the volume of the cone. You don't need to remember the formula for the volume of a cone. It's given in your data booklet, but you need to know how to use it. So the volume is equal to a third times pi times r squared times h. So that's a third times pi times, well, our radius is 2.5, so 2.5 squared. H is the perpendicular height. Be careful here. It's not the slanted height. It's not H. It's always the perpendicular height that goes straight from the center up to your apex. So you're looking at OA. And in this case, you can write 7.60, but this is a bit rounded, so it's much better to write more decimal places. Or you can use the unrounded value, or the surd here, as we call it. So the square root of 57.75. Your answer will still be correct, but it might round your number too much, and it might not be good. So just keep it as accurate as possible. Add a few more decimal places, or just use the square root value, and that should give you 49.7 centimeters cubed, and that is the three significant figures again. So a question I want to add is to find the so I need to find the surface area. The surface area, as you should know, is you adding up all the faces. So we have two faces. We have one curved face, which is this coned part, and then we have one circular face at the bottom. So the surface area corresponds to the curved face plus the circle base. The curved face has a formula already, and that is also in your data booklet. The formula for the curved face is just pi times r times L, and L is your slanted height. Okay, the keyword should be this L here, so it's the slanted height. And the circular base, the area of a circular base is just, it's pi r squared. And this is also given in your data booklet. So let's just substitute the values in. So this is pi times 2.5 times 8. And then this is plus pi times 2.5 squared. Now we like to keep things in pi, so for now in my calculator I'm just going to type in 2.5 times 8 and then 2.5 square. I'm going to leave pi as if I'm dealing with x or y or z. So this will give me 20 pi, and then this part will give me 6.25 pi. Again, I didn't do the multiply by pi in my calculator. If I did, it's going to give me a decimal number. I don't want that just yet because now I have two nice things in pi. If I have 20 pi and I'm adding 6.25 pi, I end up with 26.25 pi. Okay, it's just adding 20 plus 6.25. And I can do that because I have 20 lots of pi and 6.25 lots of pi. So you can think of it as algebra. And then you can leave the answer in this form if you want to, or you can evaluate it. So you actually do the multiply by pi and you end up with 82.5 centimeter square, and that's the 3 significant figure. And that's it. That's the final answer. So a cone might be a bit tricky, but all you have to do is substitute in the formulas given to you in your data booklet. So make sure you study your data booklet way before your exams and your tests, because it's useful to actually know what formulas you can make use of.